Hi friends, welcome to my YouTube channel. This is lecture number 18 and today we are going to start one phase half wave uncontrolled rectifier with RLE load. So this is the circuit diagram of rectifier. Here we can see that load is RLE type. RLE means load has inductance L, resistance R and EMF E. All are connected in series and we get output across this RLE load, and output is equals to V0, and this whole RLE load is connected in series with this diode, and this whole circuit is supplied with this voltage source Vs. Okay, and what is Vs? Vs is equals to Vm sin omega t, and this is the waveform of Vs. Okay, now here this red dotted line shows the EMF E, and we can see this red dotted line and this waveform of Vm sin omega t intersect at this point. So what is this point? This point is theta, or we can say that intersection of this EMF E and Vm sin omega t waveform occur at angle theta. So we will see the operation of this circuit in four angular slots. First we will see the operation from 0 to theta, then we will see the operation from theta to pi minus theta, then from pi minus theta to beta, and after that beta to 2 pi. Now first we will see the operation of circuit from 0 to theta. Suppose at omega t is equals to 0, this diode was open circuit. So there was no current in this loop, and we get Vd is equals to Vs minus E. How we get this? If we simply apply KVL in this loop, then we will get Vd is equals to Vs minus E. Okay, now from 0 to theta, here from the waveform, we can clearly see that this EMF E is greater than this source voltage Vs, because this EMF E lies above the waveform of Vm sin omega t. That's why E is greater than Vs from 0 to theta. When E is greater than Vs, then what happens? We get diode drop, that is equals to Vs minus E negative. So from 0 to theta, drop across diode is negative. Negative drop means diode is reverse bias and act as open circuit. Okay, now what is output voltage V0? We know that V0 is equals to drop across this RLE load. As current is 0, that's why there is no drop across this inductance L and this resistance R. That's why we get output voltage V0 is equals to E. So here V0 is equals to E. And what is power P0? P0 is equals to V0 into I0, as I0 is equals to 0, that's why P0 is equals to 0. And this I0 is also equals to 0 because diode is open circuit. Now we will see the operation from theta to pi minus theta. From theta to pi minus theta, what happens? This diode get forward bias, because from theta to pi minus theta, the waveform of Vm sin omega t lies above EMF E. It means Vs is greater than E. Okay, this Vs is greater than E. When Vs is greater than E, then we get Vd positive. And when we get Vd positive, then it means diode is forward bias, or we can say that diode conducts and acts as short circuit. So when diode conducts, then current I0 flows in the circuit. And as I already told you the concept, then whenever inductor is placed in the circuit, then we get current up to beta. And what is this beta? Beta is between pi to 2 pi. So this beta lies between pi to 2 pi. If you want to know more about this concept, then watch my previous lecture on RL load. So here we get current up to beta. Okay, So from theta to pi minus theta, I naught is greater than 0, and when this diode conducts, the supply voltage will appear across this diode. That's why we get V naught is equals to Vs. And what is drop across diode? When diode conducts, then drop across diode is equals to 0. So here drop across diode is equals to 0, and what is P naught? P naught is equals to V naught into I naught, and we know that V naught is greater than 0, I naught is greater than 0, that's why we get P naught is greater than 0. Now here one more important point. What is this point? We know that at omega t is equals to 0, this diode was reverse bias. So in this equation, Vg is equals to Vs minus E. At omega t is equals to 0, Vs is equals to 0. That's why we get Vd is equals to minus E. So this point is minus E. And at omega t is equals to theta, what happens? Vm sin theta is equals to E, because this is the point of intersection of sinusoidal waveform and EMF E. It means EMF and source voltage are equal at this point. That's why we get drop across diode that is equals to Vs minus E, and that is equals to 0. So that's why we get drop across diode is equals to 0 at angle theta. Now next analysis from pi minus theta to beta will be based on this equation of current I naught. And I already told you that in case of inductive load, we get current up to beta, and maximum value of I naught lies between pi by 2 and pi. Okay, actually the detailed concept behind it has been covered in one phase half wave uncontrolled rectifier with RL load. If you watch that lecture, then you will come to know what is the actual reason behind this, that we are getting current up to beta. This is quite large topic, that's why I am not telling it again, because it will consume lots of time. So this video will become very long. So if you are interested to know this concept, then watch my previous lecture. Okay, now move to next slide. What happens from pi minus theta to beta? We know that current flows up to beta, and diode will remain turned on till we get current. Okay, this concept is also been told to you. So that's why this diode will continue to conduct from pi minus theta to beta, because this diode will conduct till we get current, and we get current up to beta. So this diode will remain turned on. When this diode remain turned on, then what happens? Although from pi minus theta to beta, what happens? Although this Vs is less than E, we can clearly see that from pi minus theta to beta, this Vs is less than E. But still diode is conducting. Why it is conducting? Due to this inductor L. Okay, this inductor L make the current to flow from theta to angle beta. So this diode will continue to conduct till we get the output current. Okay, so when this diode conduct, what happens? When diode conducts, we get output voltage that is equals to source voltage, or we can say that when diode conduct, this source voltage appear across the load. Okay, that's why V naught is equals to Vs and I naught is greater than 0, and when diode conduct, drop across diode is equals to 0. So these are the waveform. Here we can see that this V naught is equals to Vs. Okay, so this waveform is exactly appear from theta to beta. Okay, now what happens from beta to 2 pi? From beta to 2 pi, what happens? This current becomes 0. After beta, this current is 0. That means this diode get reverse bias. Why this get reverse bias? Because here polarity reverses, and we get voltage drop across diode that is equals to Vs minus E. Here Vs is negative, that's why we get Vd negative. So diode is already reverse bias, but here current also becomes zero, that's why this diode get open circuited. So when this diode get open circuited, then I0 in this circuit becomes 0. When current in this circuit becomes 0, then what happens? We get output voltage that is equals to E. Because V0 is equals to drop across this inductance L plus drop across this resistance R plus EMF E. But when current is 0, drop across this LR is equals to 0. That's why we get V0 is equals to E. And what is drop across diode? Drop across diode is equals to Vs minus E. So how we get this Vs minus E? Simply applying KVL in this loop. Okay. Now we can plot the waveform for this diode drop. Here it is the waveform of diode drop. So what is the maximum value of this diode voltage in reverse direction? How we can calculate this? We can calculate this maximum value is occurred when this Vs attains the maximum negative value, because EMF E is constant. So when this source voltage Vs attains the maximum negative value, then in that case maximum reverse voltage across diode we get. So when this is maximum, it is maximum at 3 pi by 2. So at 3 pi by 2, this Vs is equals to minus Vm. That's why we get Vd is equals to minus in bracket Vm plus E, and this is 3 pi by 2. So at 3 pi by 2 we get minus in bracket Vm plus E. Okay, now what is P0? We know that I0 is equals to 0, V0 is greater than 0. Here V0 is greater than 0, that's why we get P0 is equals to 0. Friends, although this chapter is not that much important from exam point of view, but I have covered this chapter to enhance your knowledge or to make you understand the concept of rectifier more clearly and more deeply. So we will now see certain parameter calculations for this rectifier circuit. So first, that is V0 average. We know that V0 has three different equations from 0 to 2 pi. First, from 0 to theta, this V0 is equals to E, and from theta to beta it is equals to Vm sin omega t, and from beta to 2 pi it is equals to E. That's why to get the average value we have to make three different integrations. So V0 average is equals to 1 upon time period, that is equals to 2 pi. In bracket integration 0 to theta E dot d omega t plus theta to beta Vm sin omega t d omega t, plus here plus sign is missing, so plus integration beta to 2 pi E dot d omega t. So on integrating this you get V0 average. And what is this? This is current step load. Why this is current step? Because voltage and current waveforms are not similar. So that's why it is a current step load, or simply all the RL type loads or RLE type loads are current step. Okay. Now what is conduction angle of diode? Here we can see that diode conducts from theta to beta. Okay. Because diode conducts till we get this current I0, and we get current I0 from theta to beta. That's why this conduction angle of diode is beta minus theta. What is angle beta? Beta is simply lying between pi to 2 pi. I already told you. What is peak inverse voltage? That is equals to Vm plus E. This also has been told to you. And what is circuit turn off time? Circuit turn off time is the time for which diode is reverse bias. Here we can see that suppose this is 2 pi. So from 0 to 2 pi, here we can clearly see that diode is reverse bias for this period and this period, and this is theta. And what is this period? This is simply 2 pi minus beta. Okay, so that's why we get 2 pi minus beta plus theta. So this is the angle for which diode is reverse bias. So what is circuit turn-off time? It is simply equals to 2 pi minus beta plus theta by omega. I hope you like the videos. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.